there?
Let me sit down there.
Awesome.
All right, perfect.
Great talk.
All right.
Nice.
Hard to see. Okay. Can everyone hear us okay? Yes. All right, perfect. So what I would like to do is take the next 10, 15 minutes just to do a little bit of Q&A. I have a few questions for our speakers. I want to mix it up a little bit, but I would really enjoy some of the questions. There's a lot of horsepower, a lot of really interesting thoughts and dynamics going on here, and I would really like to get a very interesting back and forth, or dynamic back and forth between the audience and our speakers. So please don't be shy. One of the things I just want to start with, and this is a little bit off script, so I've done a lot of modeling, not to the same sophistication that you have, but I've done a lot of real world modeling in the financial space. And one of the issues that I have, and I've been watching, and Ken, when you talked about, hey, we modeled from 2000 to 2020, right? The question, every model that you use, whenever you set that time period becomes so influential to how you fit that model, the output, the forecast. The other thing that occurs is your forecast is what frequency do you use for the output. For example, when I first started modeling, we were always using 1 month periods or forecasts. Now, as the market has become more efficient, that forecast has shrunk and shrunk and shrunk, and depending on who you are. But with that forecast become other dynamics. How quickly can we turn over the portfolio? How much transaction costs? And the other thing, just getting back to this bigger thought process on time periods, we have regimes, right? And so conditional regimes. This environment is the current environment is very much inflation oriented. How does that influence things? How is this static model going to work? And when do we want a static model? And when do we want more of an adaptive model? And so it's really an open question. When you think about the process, how do you think about these different regimes, about the time periods? And I've heard a lot of really interesting thoughts on the tweaks of the model, but when do you think more about the data than tweaking the model? And isn't there a worry sometimes that you're trying to fit the data as well when you're doing that? So in your struggles, and I've had plenty of struggles myself, how do you confront that, and how do you, for our audience, how do you think they should best confront some of these issues?
Let me go?
Please.
Yeah, so I think all those problems are pertinent and sort of unique, right? It's an interesting, there's no same, it's like a river, right? Like there's no same river, right? There's no same economy. And I completely agree. And obviously there's a concern with my analysis, right? It's like, okay, you do really well in COVID, right? But when's that going to happen again, right? Right? So what I try to do in my analysis, at least, is one, I try to stay away from it. Mm-hmm. So I'll write the code and do some simulation stuff, and I'll send it to my finance collaborator, right? And then he'll run it on his end, right? And he's not going to tune or tweak anything. So I have sort of like a wall between us, so I don't cheat.
Okay.
Right. So that's one thing I think is a good sort of statistical practice. Yeah, no, I think it's the best I could do, right, is to have a long time period, and such that it hopefully captures a lot of different economic situations. So that's the best.
Okay.
I try to do.
But also, when you have a longer time period, you usually have a lot of less out of sample data to test it upon, right?
That's true.
And so that becomes the issue, right? So how much do you leave out of sample, right? And again, you're not trying to cheat, right? When you have a set of data, you're always trying to come up and look for things and finding things, and you're a hammer, you're always looking for that nail, right? And we have to be very careful about some of these things, because a number of things I've heard are intellectually very elegant, but in practice, how influential or how impactful and how much do we need to look and understand the data, and then how much do we need to compact these different time periods and understand regimes and exactly what's going on, and realize that part of this is statistical analysis and part of it is understanding the data a little bit more. So Jun, maybe if you have some thoughts as well?
Yeah, it's great questions. I think I was not paying
I got it from Alan.
I was not paid high enough to worry about this problem too much. So I was doing consulting for my hedge fund friends. I sometimes was asked similar questions. At the end, I think I was still trying to think more remotely as building more flexible models. And at least now, currently, I believe this Gaussian process type of models may be a way to cope with that, but I wasn't close enough to actual data to, although I was aware of the issues you mentioned, those are really tough issues.
And that's maybe a good question is when you look at financial data, today compared to say 10 years ago, do you seem to lean more on adaptive data? Do you seem to, what we would do is we would weight observations higher in the shorter term and less in the longer term?
Right, that's traditional one. One thing we were thinking is whether we could discover some historical similarities by this kind of kernel methods, trying to not just rely on time, but also rely on some other patterns of similarities. That's generics ideas.
Rong, any final thoughts or any? Because
I think actually Mike and Ken, what they're doing is partially trying to address your question. They can have multiple choices of different time frequency, different method of prediction, and they will adaptively choose the one that fits the best at current moment in a way, right? It's
okay. So I know Alan had a couple questions or two, but before we get to Alan, is there any questions from the studio audience and anything in particular? Please don't be afraid, because again, we have some great speakers up here with a high level of understanding and some deep studies. But if Alan wants to go first, I'm okay with that.
I'm Alan Carr from Temple, and the question I have for all three of the panelists, and I think it reflects what all three of you said, and to a significant extent what Mike said in his talk as well, is that what we're really struggling with right now is how to understand dependence in an era of big data and how to transform our old-time thinking that dependence was fundamentally an issue between limited data and computational complexity. And the world, so all the time historically we think there's not enough data to capture all the dependencies, so we simplify models, we do whatever. Now both the computational power has dramatically increased, and probably even more so the availability of data has increased. So my question, kind of to all of you, including Chris, is how should we be evolving our thinking about dependence in light of these changes?
Chris.
I'm going to ask Ken to go first.
No, I mean, this is sort of a paradigm shift, right? Because we have to rethink how we think of statisticians, right? Like you're trained to, especially if you're in the social science realm, you're sort of trained to deal with small data and trying to capture stuff in that. And as we move to big data, then suddenly we don't have to worry about that. We have to worry about other things. Fortunately, because I work in time series and I work in like macro and finance, I don't have to worry about it that much. I mean, I worry about dependence, but not in the sense that Alan is saying, because we have a lot of data, but S&P 500 300 years ago isn't very informative of how the economy is going to turn out next year, right? So I'm very fortunate in the sense of my modeling is dependence in time, and because of that, I'm less worried about the far past and more focused on being adaptive and coming up with adaptive solutions in the future rather than that,
Yeah, I'm not sure what I have to say. I guess there's some machine learning models are changing some ways for us, like LSTM, those type of models. introducing more structures than traditional statistical models can handle. Although those are built on the actual computer powers, and also this this Gaussian process type of models, but there's still a limitation of how much you can really compute. So I think I would intend to say that it's getting into an area we really don't quite understand. It's beyond our analytical skills more than computational skills.
I think Alan touched a very important question. We are time series. We do a lot of, we try to model dependency, but a lot of machine learning algorithms, they are all based on ID samples, whatever, right? So I kept asking those people, right, how do you deal with dependent data, right? And they gave me very simple solutions. No, I just threw in all the lag variables in my neural network and comes out, everything is fine, right? I use, your time series use past information. I'm using past information and just throwing all the lag variables. But still, I feel something is missing there, but I'm still trying to figure out, right? The string lag variables is okay, but where's what happened to, have MA, infinity lag type of things in there, right?
Right. So not surprisingly, I appreciate all the thoughts, and I have similar ones, but as a practitioner, I come at this a little bit differently. And we delve very much into the why and understanding some of the macroeconomics driving the different variables. We don't want to drain the ocean. We don't want to look at every single variable. There is some parsimony. There's an incredible amount of correlation among factors, and as some of the panelists were speaking in their talks, as you introduce more, there's more noise, and it can really skew the signal. One of the things we do want to do, and we go back and forth, and I don't know what the right answer is. We will try and quote unquote define certain regimes. Then we will take our models and apply those models into these regimes. The other thing is there are very distinct idiosyncratic events or exogenous events that change around the volatility and the correlations in the capital markets. And so either adaptive models or models that you've used in other type shock events, for me, have been very effective. One of the things that I've noticed as the techniques and the computational power has gotten stronger is you can find a signal, but exploiting that signal becomes very difficult because the decay in that signal, in many cases, becomes very quick, and you cannot exploit it. And one of the things that we also do is we take a lot of time in trying to understand where the market inefficiencies are and where it can exploit that. The market has become much more quantitative in almost every aspect of life, which is great, but it also makes it much more difficult to make money. And what we do, and the last thing I'll say is, we spend a lot more time on the risk side of the equation than the return side of the equation, because I think there's many more inefficiencies out there. But I don't, trying to drain the ocean is just a very difficult process. Lots of people like to do it and talk about how much they learn, but it's not clear to me that there's much to gain. There has to be a much more intellectually sophisticated and informed process. Yes, I can't read your name, but
Ed.
Hi. Great talks, guys. One thing that was kind of coming out, and it was most apparent, I think, in Ken's, when you were talking about taking this one big model, and then to do the ensemble, you take little pieces of it all. And that's very reminiscent of a theme that we often see in machine learning, where people convert these things into a sort of combination of weak learners. And the Bayesian predictive synthesis seems perfect for doing that. But I think that this sort of shattering big models into smaller pieces that somehow can be manageable was also in the other two talks. And you can see it there. I wonder if you guys would like to comment on that aspect.
Yeah, go ahead.
No, I think I mean, in some sense, BART is similar to that too, right? So I think it's either you have a model that builds into it, or you could take an approach that I'm doing, which is to have a two-stage process in some sense. But no, I think I find it to be more intuitive, and I think it better serves the problem, even though it's not as fancy as coming up with this very, very complicated model that somehow, sort of like a deep learning model where it's like trying to learn everything. I think it's, sometimes these practical solutions, I think, best serve the problem. And I think our job is to serve the problem, right? So.
Yeah, great question. I think there are two type of demands. One is like what deep learning is doing. They capture really complex functional forms like pictures, dogs, and so on. And the other type is like financial data. A lot of noise, as far as I understand, is probably 1% of signal at most. And as you need synthesize in some way in the form of weak learner. So you sort of need to synthesize a lot of things to get a little bit out of that. And every synthesize have a certain preference, so you sort of need a kind of assemble type of approach. I think for a lot of statistical models for this type of data, it's almost a necessity to do this, what you are saying here.
Yeah, what I can say is, obviously I don't have the same background as the other gentlemen and the theoretical, but when we build models at that from a practitioner's point of view, we do have models within our models. And this creates, as you wouldn't be surprised to know, diversification. The thing that has helped us is we start to push the weights on the things that are working to a higher level. So that's our dynamic process. And that's what you see with a lot of machine learning, is you're just moving to that space where things are working, but you're having enough information collection to be able to recognize those signals, right? And that occurs on the risk side of the equation, but that used to occur mainly on the risk side of the equation, but I'm seeing that more on the return side of the equation as well. So it's this great question.
Yeah. What I did is exactly what Ed was suggesting, right? It's a huge dimension thing. You do a transformation to make it becomes many smaller problems, but each problem has stronger, actually becomes stronger, right? But in a smaller dimension, then you pack them up and transform back. That's what we do.
I probably got to run. I probably got to go.
Oh, you have to go. Oh, okay. All right. Jun has to run, but we can stay up and answer a couple more questions.
You go, don't do it now.
If you just, I'll repeat the question if you could just say it out loud.
These things will actually be enough unless I have to be able to explain to domain person why.
Right.
Why I suggest something, yeah. And then the next question always comes, are you sure? Right? so yeah, they're really talking about uncertainty, right?
Right.
Quantification, yeah. So if you could please comment on these aspects that I have not heard enough discussed this morning.
Yeah, so let me put it in two categories. When we model, we look at things, you have an exogenous shock. And a shock, by definition, you cannot model because it's unpredictable, right? And you have to understand, and what we try and do is when we see shocks in the system, we try to make sure that that doesn't skew our analysis, because again, that's who knew that COVID was going to do what it would do. We can classify that shock with other shocks, 9/11 or things of that nature. We can look at the decay that's typically after that, but we can never predict that shock. That's by definition unpredictable. But you can find a very similar decay and similar results after that, right? So we tend to group those shocks together to get a better understanding. What you're asking is, okay, prediction. The one or two things I would impart upon you is everything from my point of view always starts and ends in the cost of capital. Risk cannot be priced if you cannot source capital. The risk becomes ridiculously expensive if I cannot get capital. So what I'm trying to say very ineloquently, most of what we do and most of what we look at in the risk starts in the credit markets and the liquidity around the credit markets. Because when you look at how credit spreads wax and wane over time, it has significant ramifications and correlations with the rest of the risk market. Because one, if you're a company that's reliant upon it, your valuation is going to wax and wane with the availability of credit, the abundance of credit, and the cost of credit. And so if I was going to say there's one thing to look at for all your clients, one thing that's a leading indicator, it's credit spreads. And what I would do is I look at credit spreads, and we do look at this in a time series fashion, but I would also combine that with the liquidity around credit spreads. How much money is coming into the market, how much is being not destroyed, but how much is that market shrinking? Because it's not just the cost of risk-based capital, but it's availability of risk-based capital as well. And so I know we don't have a lot of time, but I would just leave you with that. I don't know if the other two guests have anything to add.
No, we do time series. The foundations, we start point is stationary, then we add more and more complexity in there, changing point, and but we can never predict, as Chris said, unpredictables. But and in terms of uncertainty quantification, we always care about prediction intervals, right? That's how we do that. But it's always model-based. But with assemble of different models and different forecasts, we also try to combine taking care of the correlations among all these forecasters, but then provide a unified prediction intervals that provide certain uncertain quantifications.
I don't think I have so much to add, except I think one point would be that domain knowledge is very important, right? And all the problems that we deal with, it's you just can't come up with good solutions unless you have good input from the domain people.
Right.
And this is why I think it's very important to kind of keep that in mind.
It's that pulling of interdisciplines together, right? It's not
This
just,
is why this
Right.
conference is important.
Right. That's exactly it. We have a number of PhD students working with us. I've been lucky enough to work with a lot of very sophisticated people. I have both a quant and a fundamental background, and I also understand many different aspects of the capital markets, whether it's equity or fixed income. And what you can see is in the capital markets, certain ideas are expressed across the market. For example, and I'll be quick with this, when the Fed was doing QE, duration was expressed across the capital markets, equities, fixed income in the US, overseas, in a very big way. And that reversal of that duration is what we're seeing today. A lot of people are saying, hey, we're going into recession. What we've really seen is that the Fed basically pushed, with QE, what they did is they just pushed other people out of the way. And so they artificially pushed down the cost of capital. Real rates on a 10-year were less than 100 basis points. So what should occur is all your financial and real asset prices should go much higher than they typically would in equilibrium pricing. Well, when that turns around, right, when the Fed goes from QE to QT, then the cost of capital is now decided by, mainly by the markets, somewhat by the Fed, and so there should be a very much a reaction function in financial assets and in real assets, and that's exactly what we're seeing. And again, it's nice to say and nice to understand, but being able to quantify it and to pull in folks from the economics team, folks from the traders, from the credit team, a slew of PhDs, really it helps us refine and understand and pull the noise out and get to that signal. And I would agree 100%. It's that interdisciplinary relationship that makes things go. We have a phrase, we have a quantamental approach, right? Where it's not just quant, it's not just fundamental, but it's quantamental. And some of the best portfolios and tools I've put together are along those lines. So I think we might have time for one more question. No. I guess I'm being told there's no more questions. And it sounds like everyone's hungry for lunch, and it's time for lunch. So thank you all. We have a great group of presentations in the afternoon. I hear we also have a fabulous lunch. So thank you for your time, and I look forward to talking to you all at lunchtime.
Thank you.